Hello and welcome to section 10.5, the section on conic sections. This is where we learn about parabolas or relearn about parabolas, ellipses, and hyperbolas. And it is really useful, especially for those of us going on to Calc 3. Okay, all kinds of different shapes in 3D space based upon the conic sections. Okay, so let's start with the parabola, and we'll do a video about the parabola, and then we'll do a video about the ellipses, and finally end up with the hyperbola and maybe finding equations of conic sections. And so I anticipate 3 different videos for this section. Okay. All right, so the definition of the parabola, let's go there. It's a set of points that are a fixed distance from a given point known as the focus and a given line known as the directrix. Okay, so the way you typically develop this is, and I'm going to work on the side here, is you've got the parabola. We know what it looks like. We're going to have this guy, usually you start based at the origin, and there is something, the fixed point right down the axis of symmetry. Let's say it's got p units away, so this point would be 0, p, let's say. And then there's a directrix down here as well, and that would be the line y equals minus p. And basically the argument is we're going to grab a point xy, and we're going to say that the distance from xy to 0p and from xy to the line, the perpendicular distance to the line, are the same. They are a fixed distance from each object. Okay, so we use the distance formula, and we're going to run it on xy compared to 0p, which is what we'll call the focus, and also the point on the line, on the directrix, directly below the point, so we'll call that x comma negative p. And you run the distance formula. I'm going to go kind of quick because I'm thinking maybe you've seen it before, but we go the distance formula from xy to 0p. So we have a square root of x minus 0, so x squared plus y minus p quantity squared is equal to, okay, the distance here, x minus x, is 0. And in fact, you can figure out what that distance is, really. What it is y plus p. Okay, or you can think of it as y plus p squared, square rooted. Okay, square both sides. And this side too, so I better show that. We're going to square both sides. And we get this, and we also get y squared. Okay, so we look across the equation that we have, and we notice that the y squareds would cancel if we move them. P squareds disappear. And here's your equation. If we throw the minus 2yp to the other side, we'll have 4py is equal to x squared. That is what it looks like if the parabola is centered at the origin. Okay, if the parabola is not centered at the origin, then you'd have 4p, and then like y minus k is equal to x minus h quantity squared, where the vertex is actually h comma k. Okay, so our parabolas, they're going to open up, down. They might open left, right in our homework, so we got to watch out for that too, in which case the squared term becomes y, and x is not squared for a left or right opening parabola. So the whole skill that we bring from algebra helps us out here for sure. What I have here is I used Desmos to do a few graphs. And what I did here on this one is I graphed this particular guy. Okay, so it's 4y, or 4 times 1y, is equal to x squared. Notice the formula, 4py, and so I'm using 4 times 1y, so p is equal to 1. So the focus for this guy and the location of the directrix is easily found. You just go, well, within the vertex, or within the parabola, I'm going to go up 1 unit. That's the focus, and then I'm going to go back 1 unit, and that's the directrix. And if you needed to state it, and you do in the homework, you would say that the focus is the point, in this case, 0, 1, and the directrix is the equation y equals negative 1. So I'm just pointing that out to you, that all that stuff is findable. And what's really cool about parabolas is when light rays come in and they bounce, they all, if they're going parallel to the axis of symmetry, they all bounce to the focus. Okay, it's got that geometric property. In this particular case, I graphed 4 times 1 times y plus 2 equals x minus 3 squared. So in this case, you can say, hey man, I know what the vertex is, and you can read it from the graph. It's over 3 and down 2, and you can see those numbers right there. The vertex, you change the sign, 3, negative 2, because those are shifts in the graph or the curve of the quadratic formula there. So in other words, you got a function, and instead of going 4p y x squared, you modify what you put in for y and also what you put in for x, and that shifts vertically and horizontally your parabola, okay? We still play the same game. We notice that p is equal to 1, and so along this axis of symmetry here, we go up 1, and there's our focus. And you'd have to read from your graph and say, it looks like it's going to be, oh, it's looking like it's 3 comma negative 1. And then the directrix is y equals, what is that guy? Y is down here. So it's y equals negative 3. Okay. And then what I did later was I went, okay, what happens when you modify your focal distance? So this is for you guys to kind of look at and observe, and you can play with this in Desmos too if you want. But what we have in this case is that p is equal to 3. The next one, p is equal to 1, which we've been goofing around with. And the last one, p is equal to 1/4. And which one is which? Which one is which? So if you elongate the p value, the distance from the focus, you're going to get a widened parabola. The middle one is the one we've been playing with, the red one, but then we have, again, if you move the focus away, like in this direction, away from the vertex, the parabola widens out. And if you move the focus closer and closer this way, it's going to become more narrow. And in fact, this is the very first one we goof around with. This one just says y equals x squared. Now we know a little bit more about that guy. We know that the focus is 1/4 away inside the parabola. It's the green one. It's the green curve here. And that's really what I wanted to demonstrate to you, is that if the focal distance lengthens, the parabola widens out. If the focal distance gets shorter, if the focus and the vertex get closer and closer, the parabola gets more and more narrow. Okay, so it's a geometric property to be aware of. So when you graph a parabola and you want full credit, you're not just going to do some sort of, whatever, swoosh. Instead, you want to plot a point or two and get it right, because different parabolas have different shapes. Okay, so sketching it, basically what in the homework they ask us to do is find the vertex, focus, and directrix of each parabola and then sketch. All right, let's do these one at a time. Here's the first one. If we understood what was happening up there, we can read the vertex right away. But what do you notice about this one? In fact, that would be the first thing I'd do. There's a couple things I do first before I do any sketching. I'm interested in the vertex, yes, but what do we notice about this particular guy? Okay, do you see how y is squared there and not x? What we're used to is y equals x squared. But this time it's x equals y squared, which means it's opening either to the right or to the left. Interesting. That's what I started us off with, okay? So the question then becomes, let's explain this. Since, I'll write this in English, let's get rid of this. We'll say, since we have y is squared, it opens left or it could be right. How can you tell which is which? Well, you look for a minus sign. No negative sign indicates it's opening. If it were x squared, it would be opening up. X would be opening up in the positive direction. But since we're opening left-right, the positive direction for the x values is this way. This is the positive direction. So we know it's opening to the right. So that's a lot of information just by looking at the graph. Okay. So number one, we know it opens to the right just by the coefficient in front of. I usually look at, I just look for the negative, but the coefficient in front of y squared typically if we're in algebra. Okay. Number two, I look for the vertex. And the vertex, you just look at the numbers next to x and y, and you put it in that order. Be careful. Even though y is squared, it's still -3, change the sign, and 2. For us, number 3 is, what is p? What is the focal distance? Well, what we have is 8 is equal to 4p in our problem. There's our 8. That's typically 4p times, so we find that p is equal to 2. And we can anticipate this, therefore, what? Do you think it's going to be wider or narrower? It's going to be wider, isn't it? So I think we're good to go. What we do is we take our information down here. We have a vertex of -3 and 2. So let's see. I can't even read these numbers. I got this guy. I guess this is going to be -3 and 2 is up here. Okay. There's the vertex, -3, 2. The focus is the P. Okay, it's going to open to the right. So you're going to want to put in a number, like, for instance, you can put x is equal to 0 and solve for y. You get 2 answers. Or you can say y is equal to 0. Let's do that. Let's say y is equal to 0. If y, so I'm thinking I need an x and y coordinate pair. So I'm going to plug in 0 for y. I'm just choosing that out of the blue. So if I choose that, what I'm doing is I'm going to see where it crosses the x-axis, just for fun. And so we have a 0 minus 2 squared is equal to 8x plus 3. So this is 4. Okay. I might divide by 8. And I get 1/2 is x plus 3. So looking like x is equal to, what, -2.5? Okay, -2.5 for x. So we go back to our graph, and boy, is this one wide. Yeah, he's like right there. Am I doing that right? I hope so. Did I graph the vertex? No, I've graphed the vertex wrong. I went -3, 3. Okay, -3, 2. That makes more sense. So I'm going to actually kind of scope out the parabola. I don't have to be absolutely letter perfect, but finding that other point gives me a sense of where or how wide the parabola is, like that, okay? All right, so something like that. Now we're going to go for more stuff. We're going to go for the focus and directrix, okay? All right, I don't know what happened there. Well, we know that p is equal to 2. So what we're going to do is we're going to march 1, 2 inside the parabola and back up 2 for the directrix. With this information, we can say, hey man, I know what the focus is. And we have to do that. So the focus looks like it's -1, 2. And the directrix is looking like x this time. X is a vertical line, -5. And I think we're done. Got the focus here, we got the directrix there, and we got the vertex in the middle, and there is your parabola. Okay, asking a lot of stuff. All right, let's go to this other one. This time it's not in a nice form for us to read it, but what we do in this case is we have to work on completing the square. Okay, in order to find things. I think you don't have to do it that way, but it's a good idea to do so. So it shows you a lot of information. We need to get it in this form also so that we can find p and all that stuff. So what we'll do is I'll leave x squared minus 6x on one side, but I'll send these other guys to the other side as minus 2y minus 17. And now we're going to complete the square. Okay, so half of 6 is 3, squared is +9. We go +9 on this side. And we end up with, on the one side, we have x minus 3 squared. That's what we're looking for, right? And on this other side, what we have is minus 2y. And then it looks like it's going to be, let's see, that's minus 8. Okay. Now, what we want to do is factor out that minus 2. So I want to get y by itself. So we factor out the minus 2 and we're left with what? Y plus 4. That looking good to you guys? Okay, so now we ask the question, which way is it opening? So let's answer these questions. 1, since x is squared this time, it's either up or down, but we have this little negative in there. So this means it opens downward. Okay, 2, these numbers aren't cutting it. Number 1 is that. Number 2, what's the vertex? Well, you look at the numbers tucked into those parentheses and you change the sign. So we have a 3 and this time a negative 4. Okay, opens down, 3, negative 4. 3, what is P? Okay, well, this is interesting because people will go, well, 4P is negative 2, so P is negative 1/2. You know, I don't care if you call it positive or negative 1/2 as long as you graph it correctly. And I think we're just about ready except for maybe getting a point for this guy. So let's start graphing. It opens down, it goes through 3, negative 4. Okay, he's way down here. So he's opening downward, and we can also figure out the focus and stuff. But let's grab one more point. And in this case, I think I'll let x equal 2. So if x is equal to 2, we're going for another point. And let's do some math. What we have is 2 minus 3 is minus 1 squared is minus 2, and then y plus 4. So once again, we've got, that's 1, so it's a negative 1/2 is equal to y plus 4. So we get y is equal to a negative 4.5. So that means when we moved 1 to the left, it goes down a half instead of a whole. Okay, so we are here. And again, this guy is still a little bit wider than normal, but not so crazy like this other one. And I think that's good enough, and it's going to go off the chart here. But there is our parabola. We're going to also find the focus and directrix, so let's do that. We know that P is 1/2, so we go 1/2 inside the interior, and we say that's our focus, and also 1/2 in the background, so that's our directrix, and we tell the world what they are. So the focus is a point, and it looks like it's 3, and not negative 4, but 3, negative 4.5, and the directrix is this time y equals, it's a horizontal line, and it's backing off, it's going to be a negative 3.5. And folks, that's it. There you go. That's the story on parabolas, how to graph them and find the anatomy of each. All right. We'll see you around the corner talking about ellipses.